Today we're going to speak about sequence and series. What is a sequence? It is a function whose domain is the set of consecutive integers, often beginning with 1. For example, 3, 5, 7, 9, 11. What do we notice here? We notice that there is some sort of pattern or a way that those numbers are repeated. What is that? Let me think. 3, 5, 7. I notice that the difference between each one of them and the one preceding it is 2. What do I get? This is called the first term, A1. This is called the second term, A2. Third term, A3. Fourth term, A4. Fifth term, A5. Can you get the A6? Yes, according or following the same rule, I'm going to have, okay, this is the difference too, so next one is going to be 13. Okay, what about this sequence? What do I get? 1 over 5, 2 over 10, 3 over 15, 4 over 20, 5 over 25. What do I find out? Term 1 has 1 as the numerator and has 5 as the denominator. Term 2 has 2 and 10. Term 3 has 3 and 15. Term 4 has 4 and 20. Term 5 has 5 and 25. So what do you think the sixth term is going to be? Definitely, it's going to have 6 in the numerator and 6 times 5 in the denominator, which is 6. 30. Example. A1, 2 over 3, A2, 3 over 4, A3, 4 over 5, A4, 5 over 6. Let's try and find a relation that 2, 3 and the term number 1 have. Term number 1, 2 and 3. Term number 2, 3 and 4. What is the relation between the 2 and the first term? It is 1 more than the term. Okay, so I'm going to have n plus 1. What about the denominator? What do I notice? I notice that the denominator is, how much bigger than the 1 is the 3? 2. How much bigger is the 4 than the second term? 2. How much bigger is the 5 than the third? 2. So it is n plus 2. That is how we find out a rule. Example number 2. 3, 5, 7, 9, 11. That's the one we had a couple of minutes ago. And we know that the difference is 2. The moment we know that the difference is constant and it is 2, I'm going to say, okay, then my rule is going to be 2n. And then I try and plug in 1 instead of the n and see. If I put 1 instead of the n, what am I going to have? I'm going to have 2. But the first term is not 2. The first term is 3. So what is missing? I have to add 1. Okay, so it is 2n plus 1. And this is called an arithmetic sequence. Okay, let's try it for the fourth term. Let's plug in 4. 2 times 4, 8 plus 1, 9. Yes, I am right. This is the right rule. Let me see here. 3, 9, 27, 81. What do I see here? I see a different pattern. I see that the difference is not constant. The difference between 3 and 9 is 6, while the difference between the 9 and the 27 is 18. So there is somehow a difference. So it is definitely not as easy as this one, and not as easy as this one. So what do I find here? I know that 3, 9, 27, 81 are exponents of 3. So I have to put 3 to the power of 1, 3 to the power of 2, and so on. So what do you think my fifth term is going to be? It is going to be 3 to the power of 5. So accordingly, my rule is going to be 3 to the power of n. This part, we call it geometrical. Why? Because it is built on multiplying and not adding. Now, if I do already have a rule, and I want to find the first 6 terms of a sequence, what am I going to do? I'm going to plug in 1, 2, 3, 4, 5, 6 into my rule and find the answer. N plus 4 over n. I'm going to have 1 plus 4 over 1, which is 5 over 1, 5. 2 plus 4 over 2, which is 3. 3 plus 4 over 3, which is 7 over 3. 4 plus 4 over 4, which is 2. 5 plus 4 over 5, which is 9 over 5. 6 plus 4 over 6, which is 5 over 3. Let me have this other example. an equal to n squared. Plugging in 1, 2, 3, 4, 5, 6, I'm going to have 1 to the power of 2 is 1. So 1 times 2 is 2. And then 2 to the power of 2, which is 4. 4 times 2 is 8. 3 squared, which is 9, times 2, 18. 4 squared times 2, 32. 5 squared, 25 times 2, 50. 6 squared times 2, 36 times 2, which is 70. This is a different one. Why? Because there is a negative one here. This negative one would tell me that the sequence is going to be 2 minus, plus, minus, plus, minus. So I'm going to have alternating between plus and minus. If I plug in 1, I'm going to have 1 plus 1, which is 2. So my first term is going to have an even power, which means that my negative is going to go away. Why? Because I know that negative times negative becomes positive. So I'm not going to have a negative in this part. I'm going to have a positive. So it will start with a positive. Why? Because it has an n plus 1 as an exponent. And then I'm going to continue plugging in the numbers as they go and getting the answers. Rule. When we start with plus, minus, we know that the negative has to have an exponent of n plus 1, not only n. When we start with a negative plus, what am I going to have? I'm going to have my rule having only n, minus 1, only n. Let's have another example for that. Write a rule for 3, minus 7, 11, minus 15, 19, minus 23. What do I see here? I see a different pattern that goes plus, minus, plus, minus, plus, minus. So what do I get? I get first that I'm going to have to use the minus 1 to the power. Which power am I going to have? As long as it starts with a positive, I'm going to have my exponent as n plus 1, not only n. That's the first part. And then I'm going to look at the sequence now without having any subtraction signs. I'm going to have it 3, 7, 11, 15, 19, 23. I notice that the difference is 4. What did we say about having 4 or constant differences? Then I'm going to have 4n. I'm going to plug in the 1 and then I'm going to see, okay, 4 times 1 equals 4. Okay, I don't need the 4, I need less than the 4, so I'm going to have minus 1. Okay, that does not give me the sequence. I'm going to put 1 and 2 together. I get negative 1 n plus 1 multiplied by 4n minus 1. What if the same example exactly, but it started with negative. Negative 3, 7, negative 11, 15, negative 19, 23. Remember, it starts with a negative. So what am I going to do? Am I going to put minus 1 to the power of n plus 1? No. I'm going to have minus 1 to the power of n only. And then the same 4n minus 1. Okay? Thank you.